Okay, guys. So no new notes. Does everyone have yesterday's notes? Day 66. Okay. Possibly get those out. Did you start the take-home quiz? And I'm sorry if you have the number 5 because there's like 2 cotans on there. It's kind of a gift though, because if you got it once, you'll get it again. But with tan or cotan, make sure you first write it out as either sine over cosine for tan or cosine over sine for cotan, and just make the denominator your u. Those are going to be du over u. All right? So if in the denominator you have sine of 3x, your u is sine of 3x. Whatever. Okay, so good luck with that. And really, you can have a lot of fun checking your answers with the chain rule. Take the derivative of your answer using the chain rule. If you get back to where you started, you did it right. You'll know before you hand it in that it's perfect. All right. All right, so we're getting back to our integration leading to inverse trig. And there are 3 integration formulas that we're going to be using. Can anyone off the top of their head name one of them? All right. Nope. To inverse trig, Cameron? Well, go the other way. Okay, we're going to do it with u, so it'll be u squared plus 1, or 1 plus u squared, doesn't matter. Okay. That one? Ooh, it's doing a tough one. Okay. U. Right, that's the inverse secant rule. So maybe I should scale this up a little. Yeah, that one's the annoying one. All right, Jess. She's back. Inverse sine. All right. So today we're hoping if we're given an integral that looks tough with the right substitution, if we can make it look like one of these, we'll know what the antiderivative is. We can apply these formulas. Okay, that's what we plan to do. All right. Now we just started, I think. We said you're going to have 2 extra steps if you're going for one of those integration formulas. One of the extra steps is that the constant in the denominator has to be a 1, because in all these integration formulas, there's always a 1 in the denominator. So if it's not a 1, you got to factor it out, whatever's there, so that you'll have a 1. And the other extra step is whatever, after you have a 1 there, whatever's with the 1, that's your u squared. Just identify u squared. U squared equals, then you can say what u is and du, and it'll be all fine. Okay? So we just got to the first one in here. That was it, right? Okay. And this one turned out to be, how come it couldn't have been an ln for that one? For this one, we did it and we got an inverse tan, right? Gina, you think of something? And what would there have to be up top for it to be a du over u? Yeah, there'd have to be an x up there, right? That's why this one was not a du over u, because we would have needed an x up here. We didn't have. Okay, so now oh yeah, yeah, definitely. If this was just 4x plus 25 in the denominator, it would be a du over u. But to use the du over u, the degree of the numerator has to be 1 less. Okay? All right, so now we're looking at this next one, which looks very, very similar, doesn't it? What should we do first, no matter what? Let's factor out that 3. So we have a 3 times the antiderivative of x over 4x squared plus 25 Take a look at that and see if you have any ideas. Think about a formula that might work with this one. Any ideas? Well, the one we did yesterday, we got an inverse tan, okay, because it worked out to look, we could get it to look like the inverse tan formula, u over u squared plus 1. Yeah, like what formula I think we're going to go, yeah, what do you think u should be? Is this going to be another inverse tan? Say it again, Jillian. Bottom. This time we can make u just equal the denominator, right? So if u is equal to 4x squared plus 25, well, this time we'll have du, because what is du equal to? 8x dx. So once we get du, see what we need. What do we have to put in there? I heard it. 8. So if we put an 8 inside, we divide by 8 outside. Multiply by 8, yeah, divide by 8. So this time, we're going to rewrite it. What do we get in terms of u? It's u over u. Oh, that's our good old friend.
Please excuse the interruption at this time. Any students taking the geometry regents exam, please report to the English wing. Again, any students taking the geometry regents exam, please report to the English wing at this time. Thank you.
I wish we were. That would be fun. I didn't hear what you said. I just heard a name, so that's good. Oh, oh yeah, that wasn't. They're singing rap songs with hateful lyrics. Okay. Thank you, Emily. Oh, I need that. Okay, so we get 3/8 times the ln of, let's see, u is 4x squared plus 25. That's always positive. So technically, if we didn't have those absolute value signs, we don't need them. It's always positive anyway, right? So do you see how similar these look to begin with? But one was an inverse tan and one was an ln. All because of that x. You know, when you're just comparing them, the first thing I look for, I never look for inverse trig. That's like the last resort. I always first see if I can just do it one of the other ways, you know, make the whole denominator u. Could it be a du over u? Yeah. But this one, we were stuck because we didn't have the x up here. We didn't have the ingredients for a du. Okay, so that's why we had to go with the inverse tan. Let's try another example. All right. So we're integrating 5 over the square root of 9 minus 4x squared. What would be your first, idea for u, right? Oh, you're already going in the right direction. But if you first looked at this, what would you first try for your u? Like, what's in here, right? And like, so we might, because we would be going for like a du over the square root of u, right? But why can't I do that? Why can't I make u 9 minus 4x squared? You don't have an x up here, which you'd have to have du up there. So that's why we can't use this one. Because if you make u 9 minus 4x squared, du is negative 8x dx. You can't, if you're missing, you don't have an x. You can only put in a missing constant factor. But if you're missing a variable, you're out of luck. So that's why we're not going down that route. So now, Ryan, you can tell me what you want to do first. So we're stuck with the inverse trig, okay? Yeah, you would always want to take out the 5 anyway, even before you think about what's this going to be. Now, if you had to guess which of the 3 inverse trig functions this was going to be, which one would you, the sine, right? Because first of all, there's a square root, so it wouldn't be the inverse tan. And there's nothing out front. And also with the inverse sine, you have the constant first. Okay, and just, I like to keep a goal in mind. Where we're going with this, we're hoping it's going to eventually look like du over the square root of 1 minus u squared. That's what we're hoping, that's where we're going with this. Okay, so you pulled out a 5. Good. Now, I'm trying to get this to look like that. That's the first thing I got to take care of. Yeah. Okay, before I do u squared, I got to do something else first. Yeah. Oh. Yeah, you need this to be a 1. So if the constant in the denominator is not a 1, you got to factor it out so you'll have a 1. So let me just factor that. So if you factor, I'll just factor underneath the radical. So if you factor out a 9, we'll get rid of that square root of 9 later. What would be the other factor? 1 minus 4 over 9 x squared. And you can check if you factored it right. When you factor out anything, what you're doing, you just divide each term that you had by whatever you pulled out. So if I'm pulling out a 9, 9 over 9, that's 1. 4x squared over 9, that's that. Because we needed there to be a 1. But this, when you have the square root of a product, like when you have the square root of AB, you are allowed to break it up. Right? Never do that for the square root of a sum or difference. You can't break it up. But for products and quotients, you can. So, down here, I have the square root of 9, which is really a 3. And what can I do with that 3? Bring it out front. So what number am I going to have out front? 5 thirds. So I've got, I should go this one. So I have 5 thirds, 1 over. So I factored out the square root of 9, which is really a 3 in the denominator. So what's left down there? Well, I have the square root still of 1 minus 4/9 x squared. Let's see if that's okay. Are you okay with that step? Tell me if you're not. Okay, so we made sure we have a 1 down there. Again, we're trying to get what we have to look like one of our integration formulas. Now, what's that second extra step? Yeah, you want to identify u squared. So whatever's with the 1, that's u squared. So what do you think we're going to make u squared this time? 4/9 x squared. And sometimes the kid will say to me, well, shouldn't it be negative 4/9? No, because you want this to be 1 minus u squared. U squared is never going to be negative. I'll tell you that right now, because you got to take the square root to get to u. Okay. So if u squared equals 4/9 x squared, what does u equal? 2 thirds x. To go from u squared to u, you just take the square root. So 2 thirds x. And now it's like old stuff. Once you get u, what do we do next? Get du. So what is du going to equal? 2 thirds dx. And once we get du, we always see what we need in the problem before we convert it over. So what do we need? A 2 thirds. We need all the factors of u. So we put a 2/3 inside, and then what goes outside? 3/2. Good. Okay, now comes the fun part. So now we're going to rewrite it, and it'll look really, really nice. What's 3/2 times 5/3? 5/2. I mean 5/6? No, 5/2. I'm sorry. Whoa. Yeah, you can cancel and then multiply. There it is. I don't know. I just zoned out there for a second. Okay, now we're going to rewrite this. Say it again. Du, the 2/3 dx, that's just equal to du. Okay. Square root of 1 minus u squared, because it's the square root of 1 minus 496 squared. So it's the square root of 1 minus u squared. Woo. And hopefully, once you've converted it over to u's and du's, you know what to do. Okay, so you remember what this antiderivative was equal to? Inverse sine of u. Okay, so we have right now, we have 5/2 the inverse sine of u plus c. And then we just got to go back and put the 2/3 x in for you. So we get 5/2 the inverse sine of 2/3 x plus c. So this time, you know, when we had to get a 1 in the denominator, because it was under the radical, when we factored it out, we had to factor out a 9, but it was really a square root of 9. We had to just remember that. Any questions on this one? Yeah, sure. They're starting to love it. Okay, so that last one we wound up, we were stuck, right? We couldn't get du if we just tried to make u, you know, the big thing, what we normally do. So we couldn't get du. But how about for this next problem? Well, let's factor out the 5 anyway first. That way it'll just clean it up a little bit. So we've got 5 times the antiderivative of x over the square root of 9 minus 4x squared. This time we can make u 9 minus 4x squared. This time we can. We don't have to do the factoring and do all that. Because if we make u equal 9 minus 4x squared, I mean, the whole thing is, can you get du? And this time we can. Because du equals negative 8x dx. Right? You've got an x up there, so we can do this. So what do we do next? Yep, we'll multiply inside by negative 8, and so outside we'll divide by negative 8. All right, let's see what this looks like now. Hopefully, when we convert it over, we'll know what to do. Think about how you're going to rewrite that. Du over the square root of u. Is that right, guys? Yeah, that's good. Oh, is that ln again? Oh. No, if it was du just over u to the first, that would be the ln of absolute value of u. Du over the square root of u, what are we going to have to use? Power rule. But before we can use the power rule, what do we have to do? Bam, you got it. All right, so we're going to move it up. So what we've got is negative 5/8 times the antiderivative of u to the negative 1/2 du. Right? The only time we don't bring it up with a negative exponent is if it's a u to the first down there, because d over u, that's just its own rule. Right? But Yeah, we bring it up. Now with the power rule, let me just write this negative 5/8. What's the first thing you do when you want to apply the power rule? Add 1 to the exponent. So right now our exponent is negative a half. If you add 1 to that, what do you get? Positive a half. After you've added 1 to the old exponent, you got your new exponent, what do? Multiply by its reciprocal. So what am I multiplying by? 2. I'll write 2 over 1 just so it looks like a fraction. All right. So we got it. We got our antiderivative, but this time with the power rule. And so out front, we've got a negative 5/4. It's u to the half, so I'm just going to write that as the square root of. And u, we put in there 9 minus 4x squared. What do you think about that one? Like it? Yes. I mean, try to like go with your normal integration formulas. You only have to go to the inverse trig when you're stuck, when you don't have enough x's in the numerator to get a du up there. All right, let's, then now we got the, I got to do this next one. I don't know. This is, ooh. First of all, could I make u 25x squared? Like, because I think normally I would just look at that and I would say I want to make u 25x squared minus 4, right? But if that's my u, you know, everything hinges upon whether you can get the factors of du. Du would be 50x, right? I got an x, but it's not in the numerator. Do you see that? I don't have it. So I can't just like move that up there. Right? That's why I can't make u what's under there. So now I got to think. Any ideas what this is going to be? The inverse secant. It's everybody's favorite integral. Let's just remind ourselves down here what that is. So when you integrate du over u times the square root of u squared minus 1, you get the inverse secant absolute value of u plus c. This is the only integration formula that you're ever going to have to use where you don't have to just worry about getting a du. Usually I just say, okay, you got du there, you're done, you're ready to go. Not only are you going to need a du, you're going to have a u down here. We'll see that when we get here. This is the only one. This is the very needy integral. Very, very needy. All right, so we'll see when we get there. But anyway, we're trying to make this look like that. Well, the good news is what? Usually what do we have to do first? Well, a constant, but this time, oh, nice. Okay. So then what would we do next? Think about the extra steps if we're going for inverse trig. The 4, okay? We need this to be a 1, so we got to factor it out. Now it's under the radical, so yeah, we're really factoring out a square root of 4. So we have this x here. That's less confusing to you if I put it all under one radical, if I break it up into 2 radicals. One radical? Oh, it's less confusing if I break it up in 2? Okay, good. So I'll make it the square root of 4, and then what's the other one? 20. Remember, when you multiply back, you got to get back to here. So over 4 x squared minus 1. Make sure you understand that's factoring out the 4 out of this. All right, when you factor something out, you just divide what you had by what you're factoring out. So you put this over 4, and you put that over 4. All right. Something looks a little awkward there. Yeah, that's square root of 4 down there. That's annoying. If we bring it out, what's out front? 2? Yeah. A half. If you're pulling out a 2, but it's a 2 in the denominator, you're really pulling out a half. So we'll write 1/2 the integral Okay, here's the thing. If I put a number in that wasn't there before, then I'd have to compensate with its reciprocal on the outside. But this 4 is there. All I do is slide it out. Okay? So I have an x square root of 25 fourths x squared minus. Okay. All right. It's looking better. So now we've got our 1. Nice. What should we do next? Identify u squared. And then we can get u and everything will be all fine. Okay, so what do you think we should make u squared equal? 25 fourths x squared. Right? We want this to be u squared minus 1. So we want u squared equal 25 fourths x squared. So u equals 5 halves x. Take the square root to go from u squared to u. Got to get that du. So it's 5 halves dx. Okay. Now, with every other integration formula, as long as you make sure your du's in there, you're good. But with this integration formula, not only do you have to make sure you have du upstairs, you got to have a u downstairs. But let's first make sure we have the du. So to have a du, what do I need to put in there? 5 halves. Now, normally I would compensate right away on the outside, but I'm not going to do that yet. So I put in a 5 halves. Well, so now I have du up there. But what else? I need to have a u out here in front. In front of the radical, right now I have an x. I also need a 5 halves down here. So do I need to multiply by anything outside? No, because what if I really just multiplied by 1? I haven't changed it. That happens with the inverse secant a lot. Whatever you need for du, you need, not every time, but it can happen. That's why I wait for a second. So now it's good. So if we rewrite this now, it should look lovely. So we've got the 1 half out front. What about this whole numerator, the 5 halves dx? What can we replace that with? Du. Out front here, we've got a 5 halves x. That's u. And then we have the square root of 25 fourths x squared minus 1. U squared minus 1. And then you say, oh, I know you. Get it? You? And you see that? And so what does this equal? The inverse secant absolute value of u. And then we just got to put that u in. U is 5 halves x. So our final answer is 1 half the inverse secant of the absolute value of 5 halves x plus c. Okay. Good one, huh? Now, I didn't get to have another one like it because if I tried putting an x up top and x on the bottom, it wouldn't do anything. It wouldn't change it. So I think we're going to be able to try like one or the homework ones that are kind of tough. But before we get to that, so you're going to integrate a fraction. Yeah, regular homework. That's what I told you to do some quiz yesterday. What? So you're going to integrate some fraction. And how do you know it's going to be, you're going to have to use an inverse trig function? Like, what are you looking for? Okay, yeah, if you've got a u squared on the bottom, but you don't have an x in the numerator, that would be a great way. So in other words, the degree of the numerator isn't high enough, I can make that a general statement. If the degree, the highest power of x in the numerator, isn't high enough to have a du in the numerator. So you've heard that word, degree, right? The degree of the numerator isn't great enough to be du, or to contain the factors of the u. How about that? What if you just try making the denominator your u, or what's under the radical your u, and you don't have enough x's up top, you're going to have to go inverse trig. That's what if you do decide, okay, I've got to go inverse trig, do you remember the 2 extra steps? Okay, you got to factor out to get a 1. You're going to have to, if you need a 1 in the denominator, so you're going to have to factor the denominator so that the constant is 1. So that you've got a 1. I think we know what we mean by that. So that you've got a 1. So not a 1, you got to factor it out. And then once you've got your 1 in the denominator, you want to identify u squared. Then after that, it's okay. Identify u squared. Oops, let's put that. All right. Now, if you look at the homework sheet, there are 8 problems. I will tell you, I tried to make like 2 inverse sine, 2 inverse tan, 2 inverse secant, and 2 other ones that aren't inverse trig. Okay? I want you to look at that now and pick something that you think looks really scary, because we could do one together, because I think I know which one you're going to pick, but I might be wrong. Okay, what number did you just say? 3? 5? 1? Well, wait a minute. All right, let me just look at 1 for a second. I don't think 1's going to be a problem. Okay, but for 1, let me ask you something. Oh, okay. So for 1, if you wanted it to be a normal, let me just put this here. We'll see if it's going to be an inverse trig or not. Okay? I just put the 12 out there. This one I'm probably not going to go all the way to the end here. I just want to let you see how to approach something like this. To see if it's going to be inverse trig or not, you say, all right, what if I just try to let my u equal what's under here, right? Which is what you normally do. Are you going to have enough x's in the numerator? No, you would need next to the 7th up there. So this one is going to be an inverse trig. And which type is it going to be? Do you know? Inverse sine, right? So that one, that's how you know. I think I want to do one of the ones that's even trickier. You got one that's trickier than 1? Oh, wait, what do you do? Is that one really? Okay, wait. Okay, but after you pull out the square root of, the 16 down there, so under the radical, sorry, kids, we're back to 1. We're going to have 1 minus 9/16 x to the 8th. That's that part down there. This is your u squared. Okay? So if 9/16 x to the 8th is your u squared, what's u going to equal? 3/4 x to the, nope. If you take the square root, you're raising something to the half. You've got to halve the exponent. 4. So I don't know if you can see. Oh, yeah. Yeah, because x to the 8th is x to the 4th squared. It doesn't have to, it's going to, you got to figure out what it's the square of. So that's your u. So your du, you're going to have it here to do your inverse sine. Because you see, if you take the derivative, of the 3x yeah, maybe I should just do this one. Like butchering this. Okay, yeah, 5 is the one that I think that you'll be very thankful if we do together. But this one should lead to an inverse sine. Yeah, 5 is just hideous. Do you want to pull that constant out right away? Well, actually, we have 2 constants we can pull out. So if we pull out the constants in number 5, what's out front? 4. So we have 4 times the antiderivative. We have an x cubed, x to the 4th, Now, I always try to be optimistic and think, okay, maybe it's not inverse trig. Maybe we could let u equal what's under here. Do we have enough x's up top? No. What were we going to say, Ellie? Yes. Yeah, we pulled out the 16 out of the numerator and 4 in the denominator. So do you see we're not going to just have this, it's not going to be normal u sub. We got to go with it. We don't have enough, we don't have an x to the 7th up here, right? It's not going to work. So which one do you think this is going to be? Inverse secant. Sorry, that's why I think this is a good one to do. For inverse secant, we're going to have a du up here. We're going to need a u in front of a u squared minus 1, and we'll get the inverse secant, absolute value of u plus c. That's where we're going with this one. Okay, so what should we do? Now we know we're going for an inverse trig. 16. Now it's under a radical. So do you see what it would be by the time I bring it all the way to the front? It'd be a 4 down here. So I'm going to have a 4 over 4, which is just 1. I don't want to do too many things at once. So we've pulled out the square root of 16 out of the denominator. So what's left under this radical? X to the 8th minus 1. I think I should have done that in 2 steps. You're okay with that? The square root of 16 here, you split it to 4 outside. Okay? Yeah. All right, so now we've got a 1 down there. Awesome. So what's our next thing we got to do, the next extra step? Identify u squared. And what would that be? X to the 8th. Good. So if u squared equals x to the 8th, what does u equal? Nice. And if u equals x to the 4th, what's du? 4x to the 3rd. Okay, do we need anything as far as du goes? We need a 4 up here. Do we need anything as far as u goes? Because this one we have to check out front. No, we don't need the same number this time. So if I put a 4 in that wasn't there before, I need a 1/4 on the outside. So let's see what we have. Outside, that's really just 1/4. Numerator, 4x cubed dx. That's just your du. The denominator, we've got the x to the 4th outside. That's u. Then we have the square root of x to the 8th minus 1. U squared minus 1. Now we got it. As long as we know what that antiderivative is, we're good. So we get 1/4 the inverse secant of the absolute value of u plus c. And u is x to the 4th. So we have 1/4 the inverse secant of the absolute value, of x to the 4th. Let's see, and you don't need the absolute values because x to the 4th is always positive, but it looks pretty. So that was probably the worst one on here, I think. So remember, you can have 2 inverse secants, 2 inverse tans, 2 inverse sines, and 2 other ones like the old formulas. You guys are really good. This tends to be the toughest thing for kids, and you're hanging in there. Keep working at it. And just don't forget about the quiz. Oh, guys, I also had to change the extra help back to Thursday, but I don't know where we're going to do it yet, but we'll have extra help Thursday if you need it. Yes? Oh, oh, that's fine. I didn't check it because we had the delayed opening and stuff, so you're good. But, oh, so you need a copy. Oh, what, do you remember what number? Or you mean like the regular? Oh, that we just did. Oh, here. Yeah. Oh, okay.
Quiz.
Yeah.
Means we have a question, like a discrepancy.
Yeah.
Would you just do it sine cosine here?
Yep. And you make the denominator your
Does that
u.
look right?
So that's the right u. That's the right
Because Cindy and I got the
du.
exact same answer, except she got secant instead of cosine.
Because I looked it up online.
I didn't.
I was
I
gonna
did
ask
it
you,
by
I don't know
hand.
how you get to this,
I like the way she's doing it. I will tell you, remember with logs, if you have something out front, you can put it up. So if you wound up with positive 5 ln of secant, because cosine to the negative 1 is secant, that is equivalent to it. See how you got this?
Yeah.
If she has a negative, if you put that negative 1 times up here on the exponent of cosine,
Oh, it becomes secant.
Yeah.
Because I looked this
But
up.
then why is
and
her 5? Oh, okay. So
Because
we
the
both
mirror
have the right
you
answer.
both have the right answer, but I want you to do it like this
Okay, I'll do
because
that way. Okay.
yeah.
All right.
Mary so looks like she's could have been the most beautiful woman in the world during her time. All right, Jill. Agree to disagree, Cindy. You're like, I looked it up on.
What is that? I haven't looked at that closely. I don't know what it says. If it's anything offensive, I'm hoping it's not.